Hello, pre-calc students. I am Mr. Lowell here. I'm doing the word problems of ellipses. And sorry for being sick at home, many health complications, but I'm going to try to get these word problems done so you can have some support on your economics assignment due tomorrow. So doing your ellipse word problem, starting out with Madison. Madison is standing at one focus of a whispering gallery, 6 feet away from the nearest wall. Her friend Julia is at the other focus, 100 feet away. What is the length of the whispering gallery? How high is the elliptical ceiling at the center? So the first thing I'm going to do is draw a horizontal ellipse. All right, and then you're going to draw two foci. I'll draw focus 1 and focus 2. One thing to note is that these foci are 100 feet away from each other. All right. I guess we could say Madison is at one focus and Julia is at the other focus. Madison is 6 feet away from the wall. So Madison is 6 feet away from the wall, but the distance between the focus and the edge of the ellipse is equal for each focus. So if Madison is 6 feet from the wall, we can determine that Julia is also 6 feet from the wall. What is the length of the whispering gallery? Well, we can see the length of the whispering gallery, the length of the whispering gallery that length is 6 plus 100 plus 6. So that length is going to be 112 feet. And you just got to be able to see that that's the distance from the edge to the focus is 6. The distance between the foci is 100. And the distance from the focus to the edge is 6. So that's 6 plus 100 plus 6. All right. How high is the elliptical ceiling at the center? And in order to do this, we need to figure out that the elliptical ceiling at the center is the distance from the center to our vertex at the top. So actually what I'm going to do is I'm going to draw that 100. I'm going to draw it below so this can be properly labeled. The distance from the center to the top that's what we're trying to find, and that length is going to be B, the semi-minor axis. If 112 is the length of the gallery, that means 112 is equal to 2A. That means A is equal to 56. And C, our focal length, the focal length is the distance between the center and the focus. So with 100 is the distance between two foci, our focal length C is equal to 50. Now we can find B using our Pythagorean relation. For an ellipse, we have the Pythagorean relation that A squared is equal to B squared plus C squared. So the ellipse Pythagorean relation is that A squared equals B squared plus C squared, or C squared is equal to A squared minus B squared. Either way, B squared, which we were trying to solve, is equal to A squared minus C squared. So if we're solving for B, B is equal to the square root of A squared minus C squared. So B is equal to the square root of A is 56 squared minus C 50 squared. So B is equal to 25.21. 25.21 feet. And that's B. That is the height of the ceiling right there. That's the height of the ceiling. So that is equal to the height of the ceiling. So the height of the ceiling is the vertical semi-minor axis of the ellipse. All right, moving on to question 18. Scrolling down. All right, a water feature in the shape of an ellipse is built in front of City Hall. The architect plans to place fountains at the foci. If the pool of water is 20 feet long and 12 feet wide, how far from the center should the fountains be located? So we have our pool of water that is 20 feet long. So this length right here, that length is 20, and 10. Oh, and actually, here I messed up length and width. So let's redraw it. This is our pool of water here. Make this more accurate. We are 20 feet long. This length is 20, and 10 and 12 feet wide. This length is 12. So how far from the center should the fountains be located? If our fountains are at the foci, so this is foci 1 and fountain 1, and foci 2 and fountain 2, we need to find how far from the center. We need to find our focal length right there, C. So how do we find this focal length? Well, what we need to do is use our equation. 20 squared, C squared is equal to A squared minus B squared. This is true for the ellipse. So C is equal to the square root of A squared minus B squared. And if C is equal to the square root of A squared minus B squared, that means C is equal to the square root of, well, what's A? 20 is equal to 2A, so A is equal to 10. And 12 is equal to 2B, the length of the minor axis. So the semi-minor axis is equal to 6. Major axis is 20, semi-major axis is 10. So this is 10 squared minus 6 squared. So that's 100 minus 36. So that means C is equal to the square root of 64. The square root of 64 is 8. So that's equal to the square root of 100, 10 squared minus 6 squared, 36. 100 minus 36 is 64. Square root of 64 is equal to 8. So the fountains should be 8 feet from the center. Eight feet from the center. The moon travels around the Earth in an elliptical orbit with Earth at one focus. The major axis of the orbit is 768,800 kilometers. The minor axis is 767,640 kilometers. Find the apogee and perigee, the greatest and smallest distance from Earth center to the moon center. So here's what we have to do. We have to draw the orbit of the moon and then draw the Earth. So this is our orbit. The moon travels in an elliptical orbit, and the Earth is at one focus. So here is the Earth at a focus. Okay, that's the Earth. And the moon is orbiting around this focus. The major axis of the orbit is 768,800. So the major axis, 2A, is equal to 768,800. All right. And the minor axis, 2B, is equal to 767,640. So first of all, we have the major axis and the minor axis. We need to find the semi-major axis A and the semi-minor axis B. So just to be safe, I'm going to pull up the calculator. $768,800 divided by 2 is this, 767,640 divided by 2, this value, so that's 384,400, 383,820. 384,400, 383,820. Okay, so that's A and that's B. So now that we have our drawing our center, we have our value which is equal to A, which is our vertex to the center, and we have our value of B. So we have B and we have A. What we need to find is C, because this distance is C, this distance is A. So let's draw that in colors. The distance from the focus to the center is C, and the distance from the edge of the ellipse to the center is A. And this is true for the other focus and for the other semi-major axis. Okay, so the perigee, so the apogee, which is the longest distance, is just 2A. So the apogee is the longest distance. So the major axis is 2A. The apogee is going to be the longest distance that you can have from the Earth to the place where the moon could be, and that's going to be the distance between when the Earth is at the focus and when the moon is in this location right here. So that apogee is going to be C plus A. So our apogee is C plus A. So let's solve for C. Apogee, that's equal to C plus A. So once we plug that in, let's solve for C. C is equal to the square root of A squared minus B squared. So the square root of A squared minus B squared. We can find the square root of A squared, 384,400 squared minus B squared, 383,820. That's 21108. So C is equal to 21108. Okay. And so A plus C is going to be 21108. C plus A, which is 384,400. for 400. That's going to be 405, 508. So our apogee is 405, 508. Now the perigee is going to be the shortest distance between our Earth at the focus and where the moon could be. So our perigee is going to be in this location right here, as I've marked out. It's in orange. So the perigee, so you see this distance right here, that is A minus C. So that's going to be equal to A is 384,400 minus C, which is 21108, and that's 363,292. This value is 363,292. All right, so that's the walkthrough for the word problems for ellipses. I hope you have a great day.